Hello guys, it's Mr. Win again, and today we're going to talk about literal equations. Alright, I gave you the definition here, but literal equations are just equations that contain two or more variables. So not only x, not only a, b, c by themselves, but also other variables such as y, whatever it may be. So I did write a couple examples for you, and tell me if you can recognize these. Looking at the first example I've got, okay, right here. A equals 1/2 BH. So that literally says A equals 1/2 times B times H. And if you recognize this equation, you notice that B and H stands for base times height, and 1/2 of base times height. This is actually the equation for the area of a triangle. Okay, let's look at the next example. This one may be more familiar, but P equals 2L plus 2W. So if I were to draw this out, all right, I have an L here, okay, a W here and W here, right? 2 times L, I got my two L's right here, and then 2 times W, there's two W's. And if you notice what I just drew, it's the equation for perimeter. And lastly, this last equation might be a little more unfamiliar, but it's how to get from Celsius to Fahrenheit and vice versa, dealing more with science, which says Celsius degrees equals 5/9 times Fahrenheit minus 32. So these are equations you may have seen before, you may have not, but if you notice, each one of them have at least two or more variables. So if you see the first equation, I have an A, okay, A here, a B, and an H, right? 3 variables. The second equation, P, L, W, 3 variables. And then even the last equation, C and F, 2 variables. All right. Now let's solve some examples and go over how to actually solve these equations. Okay. There we go. Alright, so let's look at the volume of a rectangular prism. Okay, the volume of a rectangular prism is V equals LWH. Solve the formula for L. Now, again, literal equations are just two or more variables, but really you're not taking any different steps to solving an equation if there was only one variable and several numbers. You use the same process you use to isolate the variable in any other algebraic equation. And again, I'm going to write it at the top, isolate. Okay, isolate means, to get the variable alone, get the variable by itself. And if you look at the problem, right, it tells us what we want, to isolate for L. Okay, so I'm going to isolate L. Let's highlight that. To highlight that, I'm going to box it in blue, okay? L is what we want. And let's look at the equation and literally read what it's telling me is being done to L. So we know V is on the other side. V equals, now it says L, okay, times both W and H. And when you isolate, keyword again, isolate, what you're doing is you're doing the inverse operations. So you do the opposite to cancel, right? So let's highlight that L again, okay? Now, what's being done to L? We see it's being multiplied by both a W right here and an H, okay? And to do the inverse operation of multiply, the opposite of multiply, we're going to divide. So I'm going to draw that line. We're going to divide by, okay, the whole equation by both a W and an H. And of course, when you do an operation to one side, so we just divided on the right, we also have to divide on the left, W, H. But if you notice, if we divide by W, don't the W's cancel? If we divide by H, don't the H's cancel? So if you see now, V divided by WH equals, what's left on the right side, the blue box? L. Isn't L isolated? That would be our answer. Okay, even though it's all letters, now we know what L equals. L equals V, the volume, divided by WH, the width and the height. So we're kind of dealing with a rectangular prism, equations that can be used in real life here. We're talking about volume, width, and height, but maybe we want to find the length. We know everything else, but we need to find the length. We can put straight numbers into V, W, and H, and don't have to worry about this initial equation. It's already set up for us to where we know what L equals. Okay, let's try another example. All right. This is another literal equation. It says the formula for density. Density is D equals M divided by V. That's mass divided by volume. So there's two steps to this, okay? The first problem says solve the formula for V, okay? Formula for V. So if we look at the equation, it says D equals M divided by V. And I want to isolate the V. So I'm going to go over here. Let's box that V, okay? That's important. I want to isolate the V. But if you notice, V is on the bottom of a fraction, okay? It's M divided by V. So the easiest thing to do here is what's being done, okay? The V is being divided. So let's multiply both sides by V. Multiply both sides by V. And I put parentheses. Parentheses, when you have parentheses, you multiply. So V times D is just going to be V, okay, times D. I'll leave it as it is. Equals M. And if you notice, both V's cancel out. So all that's left on the right is an M, okay? But again, V's not alone, but it did move to the right side. Okay, we are getting a step closer. Even though we didn't cancel out everything being done to the V, we moved it to the top at least, so it's no longer on the bottom of a fraction. So what's left is V times D, and then again we do the inverse operation. So the opposite of multiplied by D would be divided by D. So if I divide both sides by D, these cancel out. We're left with V equals mass divided by density, M divided by D. And that would be solved for V. Okay, so the same formula, density equals mass divided by volume. If I, for some instance, wanted to solve for volume, I can just straight plug in the equation or the numbers for mass and density, and I have my volume. Okay, that's the equation. Because if I go back and look at this equation, say for example, D is 2 and M is, let's say, 3. Let's say for mass is 3, the density is 2. Okay, now it might be a little tricky if I try to plug it into the original equation here. If I try to plug it into the original equation, it would be 2 equals 3 divided by V. And then again, to solve for this, I'd have to do the same exact steps. Multiply by V. V's cancel. Multiplied by V. And then I got V times 2 equals 3V. And again, have to divide by 2. Oh, excuse me, that V is canceled. So over here was actually just a 3. Okay, and then divide by 2. V equals 3/2. But look at my literal equation, the one that I already solved for and switched to where the V is isolated. If I have D equals 2, M equals 3, I can go back to my solved equation and just say V equals 3, so M is 3, D on the bottom is 2. And we still get the same answer. We just saved ourselves a couple steps. So that's why a lot of times it's easier to switch around these equations to where, we're isolating the variable we want. Okay, that's how you solve for V. It's just the same as working for numbers. We're doing the exact same operations, inverse operations, to isolate the variable that we're looking for. So let's solve the next part. It says solve the formula for M. So if I have the same equation, D equals MV, this time I want to isolate the M. So if I box my M, okay, what's being done to that M? Well, it's being multiplied or divided by V, right? What is the inverse operation of divide? Multiply. So I'm going to put parentheses and say multiply. So these V's cancel out. And then now we're left with V times D. I can just say V D equals M. Because the V is now canceled, that would be our final answer. Or if I just flip around, mass equals volume times density. Okay? Alright, moving on to a couple more examples. Alright, just a couple more practice problems that we can go through, solve for these little equations. So if I look at it, I've got solve c equals 2 pi r. What are we solving for? R. Okay, so let's rewrite my equation. C equals 2 pi r, and let's highlight the r. I'm gonna box it. Okay, so now what's being done to the r? Well, this literally says, okay, C equals 2 times pi times r, and they're all being multiplied. So what's the inverse operation? Divide. So let's go ahead and divide by both the 2 and the pi, which cancels it out on the left, or the right, excuse me, but make sure we do the same operations that we did on the right side to the left side. So now C is being divided by 2 and r. So if I rewrite my equation, C over 2 pi is now equal to r. That's the same as saying if I flipped it, r equals C over 2 pi. So we solved it. We moved the equation around to where it says r equals. We solved for r. All right. Let's try example 2. Solve v equals pi r squared times h. So again, we're solving for h. So if I write my equation, v equals pi r squared h, let's highlight the variable we're looking for. We're trying to isolate the h, okay? And what's being done to the h? Well, it says v equals pi r squared h. That means pi r squared times h. So let's go ahead and do the inverse operation. So we know it's being multiplied times, right? The opposite would be to divide. So divide by the pi r squared. I want to do the same to both sides. So these pi's cancel, these r squareds cancel. Do you see how the h is now isolated on the right? It's alone. So that means v over pi r squared is now equal to h. Or if I rewrite this, just flip it, h equals v over pi r squared. Alright, let's try another one. Solve PV equals nRT. And again, when letters are next to each other, all that's happening is we're being divided, okay? So if I look at this, what am I trying to isolate? Well, I've got PV equals nRT, and I want to solve for T. So let's go ahead and put a box around it, okay? Now what's being done to the T? I want to cancel everything. I want to isolate the T. Cancel everything being done to the T. Well, I notice there's an N and an R next to it. That just means N times R times T. And the opposite of times, or the opposite of multiply, is to divide. So divide by N and R. And I got to do it to both sides. Divide both sides by N and R. So N's cancel, R's cancel. Now we have PV divided by NR equals T. Or of course, just flip it. T equals PV divided by NR. Alright, one more example. I've got solve D equals RT, solve for T. So I'm solving for T. So let's box that. Okay. Well, let's rewrite my equation so I get a little room. D equals RT. And what am I solving for? It says for T, so let's box T. Now if I look at it, what's being done to the T? Well, it's being multiplied by an R, right? Isn't the R right next to it? What's the opposite of multiply? Divide. So divide both sides by R. That cancels. I'm left with D over R, D divided by R, equals to T. If I just flip it, T equals D over R. And that's my answer. Alright, that's literal equations. Alright, hopefully you guys got that. And that's it.